All right, chemistry time. We're talking today about, I've already written up here part of it, we're going to label it, it's going to be mostly electron configuration, so we'll just call it that. We're going to talk a little bit about Heisenberg uncertainty principle also, which is not really included in electron configuration. The first thing we need to talk about is look at there's this nice little picture on page 154 in your book. This is the shapes of the orbital as they exist in real life. Like I was telling you about when we did the structure of the atom in the last chapter. In reality, the shapes of the orbital are these on page 154. So someone at each table should have their book out. Camden, because I see you do, what is the rough shape of the S orbitals? Yeah, but in 3 dimensions it's a sphere. And then the P orbitals, look at, there are 3 different shapes of P orbitals. What's the difference, what's the only difference between the 3 different P orbitals? So what we're looking at there is a 3-dimensional Cartesian coordinate system. You're aware of a 2-dimensional Cartesian coordinate system where it's the X and Y axes. The 3-dimensional one also has a Z axis. It depends on what we're using it for, but what we usually think of for this is that if our Cartesian coordinate system, like you're used to using in math, is laid on the ground, X would be forward and backward, and Y is left and right. I'm doing this relative to me. But X is forward and backward, Y is left and right, and then Z is up and down. So we have 3 different shapes of P orbital, and they are Px, Py, and Pz. And what's their shape? All of them. How would you describe that?
A bow tie.
Oh, that's cute. Yeah, a bow tie. They're kind of like that. So this would be Px. Py would be going into and coming out of the board. I drew it at an angle. Imagine that's perpendicular. Py, and then Pz would be going up and down. So altogether, how many orbitals is this? 3. It's 3 orbitals. This is supposed to be a sphere.
Oh, they're infinity signs.
Yeah, kind of, sure. What we usually call them and what your test asks is dumbbell. That's what they call them, it's dumbbell shape. You know what a dumbbell is. Mitch does. That's how you get yoked. Yep.
I'm not very good at drawing this.
You don't have to be good at drawing them. And then the d orbitals is the other one your book talks about. I'm not going to write down all the different ones of these, but effectively there are 4 that are like double dumbbells. And then there's one that's a weirdo. It's like a dumbbell with a double orbit around its middle. These are d orbitals, examples of d orbitals. And they are dxy, dzy, dxz, dyz. They're all those different ones. And then the weirdo, which is called dz squared. You don't need to know those. You need to know the 3 basic shapes. Spherical for s orbitals, dumbbell for p orbitals. Bow tie is better, infinity sign is better, but they're called dumbbell. And then the d orbitals are flower shaped. I don't know. Your test doesn't ask that. There's no certain shape. And this one's a weirdo. And the f orbitals, which there are f orbitals, are even weirder. Some of them are like double flowers. And then there are f, and we'll just put f weird. There are pictures we can look at online after this about, or maybe tomorrow, about what the f orbitals look like. Your book only shows s, p, and d orbitals. So from this, you're responsible to know what these different orbitals look like. Aye, aye?
Aye, aye.
Okay, let's, we're now going to move on to electron configuration, which is this thing. This is what's called an Aufbau diagram. Aufbau diagram, named after a human being named something Aufbau. Yeah. Tell me his first name, book. His or her. Probably a him, because this was in the late 1800s. Well, may or may not have even had. Oh, no. how stupid and wrong I was. Be nice to yourself. It's actually not named after a person at all. It's named after, I'm just finding out, for the first, I've told people for years it's named after a person called Aufbau. It says in my book, the name Aufbau is derived from the German Aufbauen, which means to build up. You knew that, because you speak German.
No, I didn't hear it because I read it. I'm writing down the book.
She knows because she read it. Oh, some people are smart, whatever. Okay, anyway, no, the Aufbau, this is the Aufbau diagram, which I will give you a hint, because it's called to build up, and those of us who are intelligent and can read, or those of us who speak German, know that. The Aufbau principle is that, what's the matter?
Can I sharpen my pencil?
Oh, yeah, you can. The Aufbau principle is that electrons inhabit the lowest energy level available. That's fairly simple. There are 7 principal energy levels. There are 7 principal energy levels. An electron is most likely, or does, at its minimum energy state, what we call the ground state, inhabits the lowest one it possibly can. It gets as, when I say the lowest, what does that mean? It means the nearest to planet Earth? No.
Nearest to the nucleus.
The nearest to the nucleus. It inhabits the nearest to the nucleus first.
What is the lowest evenly?
Energy level available. Lowest energy level available. The Aufbau principle, I'm going to move over to this side now. The Aufbau principle is that. This thing over here is an Aufbau diagram, but the Aufbau principle is what we just talked about. And what does Aufbau mean? We were just learning, some of us.
It means build up.
To build up. It builds up from the bottom. So it inhabits the lowest energy level it possibly can first. Okay, so if an element has only one electron, which element only has one electron in its ground state? Let's be clear about ground state first. What does ground state mean? I just said it, but just someone else say it so that we're all on the same page.
It was
It's lowest
the lowest.
available.
Closest to the.
Yeah, ground state means when it's not charged, when it has the same number, when it's uncharged, when it has the same number of protons and electrons. Okay? So it's at its ground state. So which element, when it's at its ground state, has one electron?
Hydrogen.
Hydrogen. So hydrogen has one electron. Where do I put it? On this diagram, this is all something you don't even know about yet, but where do I put it?
1s.
1s, yeah, you just guessed it. What might, just based on what we already just did, what might the 1 mean?
Energy level.
Energy, write this down please, level 1. Even if you're not drawing the whole diagram, which you don't have to, write down that in 1s, the 1 is what we call the principal, oops, spell it right though, energy level. We specify principal energy level because we're talking about energy levels upon energy levels here, but the principal energy level is synonymous with just what we would normally call the energy level. When we're doing the Bohr model, those orbitals that we draw are energy levels. I will use the words orbital and energy level and electron shell interchangeably throughout this entire thing, so let's just make those all synonymous in our minds. Orbital is the same thing as energy level, is the same thing as electron shell, is the same thing as principal energy level. We can even call it quantum level, but the list goes on. Okay, and when I say I should do, not equal, but approximate, there are nuanced differences between them, but they're more or less the same. And when I use them in the level of high school chemistry, I mean the same thing when I say any of these. And I will use them repeatedly and interchangeably, and so you can too. So, which element have we represented by having just one arrow? You don't even know what the arrow means yet, but which element have we represented by having just one arrow in one box?
Hydrogen.
Hydrogen, how do you know?
Because it has one atom.
It has,
one proton.
okay, and therefore?
It is
Has also one
electron.
electron. Because what we're doing with this are organizing the electrons. But you're right, since since hydrogen has atomic number 1, it has one proton, and since it's in its ground state, it has one electron, and so therefore we put that one electron in the lowest state it possibly can be, the Aufbau principle. Without even knowing it, what does this little s probably represent, we already said? Someone already knew it. What's the s mean? Well, look what else we've got here. There are S's, there are P's,
Shape.
and there are D's. So the S represents the shape. And then if we're doing specifically hydrogen, we would say hydrogen is 1s, little baby 1. We don't say, students because they know math are tempted to say to the first power, that's wrong. Don't say to the first power. We pronounce this 1s1 is how you say this. So we had principal energy level is 1, the shape is S. What's a little 1 probably represent? You just guess.
Charge.
Well, not charge, but not atomic number, number of
Electrons.
electrons. It's the electric configuration, number of electrons. So in this notation, which we call electron configuration notation, what in tarnation? In electron configuration notation, I'm going to do that in a different color. This here is electron configuration notation. We get all the information we need about how the electrons are organized in hydrogen. Once again, the big one is what?
Principal energy.
Principal energy level. The little baby S is shape. I guess not little baby S, but the little S is the shape of it, which happens to be S. What is that shape, by the way?
DP. Oh, it's the
Spherical.
here.
And the one little baby one means
Number of
number of electrons. So hydrogen has 1 electron in its first energy level. That's all that tells us, okay? So that seems kind of overkill. But for hydrogen it does seem like overkill, but it won't once we get to the next, some more complicated ones. The second rule is what we call the Pauli exclusion principle. This one I'm almost certain is named after a person, don't at me. Pauli exclusion principle. What can you already tell? Ooh, what is going on here? Pauli exclusion principle. What can you already tell is going to be the purpose of the Pauli exclusion principle? To do what? What is the
Which
verb?
one?
Yeah, to take out, exclude. So what are we going to be excluding probably if we're doing electron configurations and we're talking about
The
excluding?
outermost.
No, just what general? What general?
Electrons.
Electrons. We're going to be excluding electrons. What this says is that 1 electron of each spin can occupy each, each, right? Gosh, here I'm talking about the dang Pauli exclusion principle and spelling the word each wrong. One electron of each spin can occupy each suborbital. Sub meaning
Below.
below. What part of this is probably the suborbital? The
The
shape is the suborbital. Okay, if I drew an up arrow, in the box, and 1 electron of each spin can occupy each suborbital, what else might go in this box if I'm talking about the next element? What is the next element? BT dub? Helium. So if I have an up arrow, what probably comes next? A down arrow. Each electron has its own spin. Electrons can have an up spin or a down spin. Side note, electrons can have, and in fact they must have, an up spin or a, look how he spelled or. Or a down spin. Electrons can have an up spin or a down spin. So according to the Pauli exclusion principle, can any more electrons be in this suborbital? Nope, because it's got 1 up and 1 down. There are only 2 spins, up and down. So our boy Pauli says only one electron each can occupy the suborbital, 1 up and 1 down. How many electrons altogether in this suborbital? This is helium.
Dose.
2. There are 2. How many can this orbital hold? Dose. And so the 1 orbital is done. What do we go to next? Well, we go up the energy levels. I had drawn over here increasing energy level. I kind of got lacerated by all this pink going on. But this arrow says increasing. Boy, this is messy. Energy, period. Increasing energy is what it says. So as I, according to the Aufbau, add more electrons, where does the next one have to go? If I go to, what's my next element? lithium. So I've got helium here. If I had one more electron to make it lithium, how do I know it's going to be lithium?
It's going to be an up.
Okay, an up, and where?
At the end. I don't know.
Well, it can't go here.
In the 2?
In the 2s. We're going up to 2s. So 2s, what's its principal energy level?
2.
2. So in the Bohr model, we would draw this in the second circle. What shape is it?
Sphere.
S. Yep, it's a sphere. And right now, so lithium's is, so hydrogen's was 1s1. Lithium's is what?
2.
Well, we have to list the whole thing. So it's 1s2, right? 1s2 has 2 in the 1s, and then 2s1. You with me so far? Does anyone have questions so far? What should all these add up to? The little babies. They should add up to the number of electrons total.
Girls and boys basketball meet
That's
at
going to come in loud and clear on the mic.
p.m.
There's the mic.
Girls and boys basketball will meet at 3:45 in the gym today. Thank you.
Great. That's perpetuated forever on the video now. Okay. So now, in order to skip ahead a little bit, so what would this one be then? I'm not really fucking fancy.
Beryllium, I can't
Beryllium, which is terribly poisonous. Now after beryllium, if I put 1 in here, come on, beryllium. This was beryllium.
Don't we already got 2?
Now I'm gonna put but now I'm doing the next one. So
Oh, we're doing boron.
boron. Now look where I've gone on the periodic table. You can't see this on camera, but look up your own dang periodic table on the Google. I've gone over to where?
Boron.
Yeah. So here's a little hint, and we're getting a little bit ahead of ourselves, but I want to kind of finish up because class is getting over. This over here, this is called the S block. All of these will always end with something S, something else. Okay? So hydrogen was 1s1. Lithium was 1s2, 2s1. Right?
Right.
Well, beryllium would be 1s2, 2s2. And then boron is 1s2, 2s2, 2p1. What do you think this block is probably called? P block. P block! What do you think this one probably is?
That's a block.
No?
That's
Guess. Just guess.
D.
D block. What do you think down here probably is?
F.
F. So that's a little hint. If it says, do the electron configuration notation for arsenic, and yours doesn't end in a P, you're wrong. Okay? So those are the different blocks of the periodic table. That's actually something from chapter 6 that we'll talk about in chapter 6. But let's do the very last rule for this. We had the Aufbau Principle, which is that they go in the lowest one first. We fill them up from the bottom. The Pauli exclusion, which is that one electron of each spin can occupy each suborbital, which means basically there must be how many electrons in each suborbital. If there are 2 spins and one of each goes in, we have 2 electrons total. And then the final rule is Kuhn's rule. Okay? Okay, this is named after a person too, maybe, don't at me. Kuhn's rule. Electrons of one spin occupy all suborbitals before electrons of the other. So basically, and that's kind of confusing, but basically what it means is that when we're starting to fill in the 2p blocks, we don't go up, down, up, down, up, down. We go up, 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 down, down, down. So as I have it written now, tell me what my electron configuration would be. Don't tell me what element. Just let's go through the electron configuration. Where do I start?
Oh, sorry.
Where do I start? Where do I start when I'm looking at this thing to tell the electron configuration? According to the Aufbau principle? The lowest. So I write down what? 1s. How many?
2.
2.
2s2.
2s2.
2p4.
Yep, 2p4. So now let's check out what element that is. Well, we know
4, 5, 6, 7.
1s2 is helium.
4.
2s2 is beryllium. 2p1, 2p2, 2p3, 2p4. So it's oxygen.
Oops.
Oxygen. Verify using the periodic table. This periodic table lists the ground state electron configuration. Look at it. You see it there underneath? It has oxygen, then its symbol, O, then its average atomic mass, then it has its something, density, and then below it, look, 1s2, 2s2, 2p4. It just says p4, but it means 2p4. I'll give you a worksheet about these developers wrong. We'll do more of these tomorrow. This is all the information. So we're through, but you need more practice. There are also quite a few little hints that we didn't get to, but I will give you a worksheet on these. Well, I'd like to give it to you now, but you have places to be, I'm sure. Bye, Mitch.
See ya.
Oh, by the way, what color is that light perceived by humans? It said in number 3. Did anyone find that? No. Okay.
I guess one.